avocodus. Similar to sequence diagrams, communication diagrams are subtypes of interaction diagrams and show how objects interact with each other. Communication diagrams, or as they were called prior to UML 2.0, collaboration diagrams, essentially are the extensions of object diagrams that show these objects along with the messages that objects send to each other. The main purpose of communication diagrams is model the messages passing between objects or roles that deliver the functionalities of use cases and operations, model mechanisms within the architectural design of the system, capture interactions that show the passed messages between objects and roles in collaborations, model alternative scenarios within use cases or operations that involve the collaboration of various objects and interactions, and support for identification of objects, hence classes, and their attributes, in this case message parameters, and operations messages that are involved in use cases. Let's analyze a simple example of a communication diagram where objects, for example actors in use cases, are drawn as rectangles. The objects are object 1, object 2, object n-1, and so on until object n. Messages passed between these objects are represented by labeled arrows that start with the sending object or actor and with the receiving object. Examples of messages passed between objects are marked as message 1, message 2, message 3, etc., where the numeric prefix of the message name indicates its order in sequence. Object 1 first sends message 1 to object 2. Object 2 in turn sends object n-1 a message 2, and so on. Messages that objects send to themselves are referred to as loops, for example, message 5. Or here is another example, hotel room reservations. Each message in the diagram has a sequence number. The top level message is number 1. Messages sent during the same call have the same decimal prefix, but suffixes 1, 2, etc., depending on when they occur. Communication and sequence diagrams are similar. They are semantically equivalent. It means they represent the same information, and we can turn a communication diagram into a sequence diagram and vice versa. The main difference between them is that in the communication diagram, the elements are organized according to space, and in the sequence diagram, according to time. So in which case we would want to use a communication diagram instead of a sequence diagram? First of all, communication diagrams are very useful for visualizing relationships between objects that collaborate with each other to perform a specific task. This is difficult to determine from a sequence diagram. In addition, communication diagram can also help to determine the accuracy of a static model, for example, class diagram. Here is a real-world example where we can compare both diagrams in action. The process of returning a book to the library. Imagine a student brings a book to the library and a librarian brings up records to check whether the book was returned on time and whether the borrowing period was exceeded. In that case, there may be a fine. In essence, both diagrams contain objects and messages, and it becomes obvious that it is much easier to determine the time ordering of messages by looking at this sequence diagram, but it's easier to see the relationships between objects by looking at the communication diagram. Objects involved in communication are of two types: supplier and client. Supplier objects are objects that supply the method that is being called and therefore receive the message. Client objects call methods on supplier objects and therefore send messages. Connectors drawn between objects in communication diagram are links that allow to establish relationships between objects and show the ability of objects to send messages to each other. If an object sends message to itself, then such a link is represented as a loop icon. The loop can be seen on both the UI object and the transaction object. Messages in communication diagrams are shown as arrows pointing from the client object to the supplier object. Typically, messages represent a client invoking an operation on a supplier object. Message icons have one or several messages associated with them. Messages are composed of message text prefixed with a sequence number. This sequence number indicates the time ordering of the message. For example, in this diagram, we can follow the sequence numbers to determine the order of messages between objects. The first message in the communication diagram is always numbered 1, the second 2, and so on. We can indicate that the message is nested within the parent message by adding a decimal point and additional digit to the parent's ordinal. For example, the message call AMT can borrow, that is, calculate for how long the book can be borrowed, is the first nested message in the inquire borrower, literally request the details of a person who borrows, and is given a serial number 1.1. The second nested message in inquire borrower is display invalid MSG, that is, display an error message, therefore is given a sequence number 1.2. Let's look at the example of transition from a sequence diagram to a communication diagram. The client creates a transaction and performs an operation with messages A, D, and O. After that, another two transactions put values of P1, P2, P3, and P4 to the database. More after that, the client receives a message that the transaction was completed. And finally, the transaction is destroyed. And now the same sequence of operations, only on the communication diagram. The client creates a transaction, performs an operation with messages A, D, and O. Next, two transactions put values of P1, P2, P3, P4 to the database. And after that, the client receives a message that the transaction was completed. Finally, the transaction is destroyed. There are a few things to watch out for. Control focus, also known as execution occurrence or activation, shown as a tall, thin rectangle denoting the period during which an element performs an operation. The top and bottom of the rectangle match the start time and end time respectively. In a communication diagram, the control focus is explicit and can thus be represented by the message nest numbering. Finally, I would like to show a communication diagram in a format that is also used in some occasions and is called the reliability diagram format. We can model objects and instances of actors in communication diagrams, along with links and messages describing how they are related and how they interact. The deposit element in the diagram describing the recycling machine system describes what happens to the particular objects in terms of how the objects interact, send messages to each other, and so on. You can create a communication diagram for each variant of the use case flow events. Please give this video ample